All right, in this lesson, we're going to factor what's called perfect square trinomials. And even before I mention what that looks like, let's just recall something from last semester. So if you were asked to multiply, let's say we had this, multiply x plus 5 squared. All right, x plus 5 squared. Now remember, x plus 5 squared means x plus 5 times itself. That's what that means. And then if I use the FOIL method on this, I get x times x, which is x squared. The outer is 5x. The inner is 5x. And the last is plus 25. And I want you to notice that when I square a binomial, no matter how many examples I do, let's say I do something like 3x minus 2 squared, and 3x minus 2 times 3x minus 2. And again, I do the FOIL just like I did this. 3x times 3x is 9x squared. The outer is negative 6x. The inner is negative 6x. And the last is plus 4. What was the saying, though, was that no matter what binomial is being squared, notice the outer and inner. In every case, the outer and the inner are the same. The outer and inner are the same. So I'm going to get x squared plus 10x plus 25. Here I'm going to get 9x squared minus 12x plus 4. Okay? All right, so that was a review from last semester. Now we're going to come back in a little while and kind of talk about these again, but basically when you're squaring a binomial, you write it times itself. You write that base, x plus 5, that binomial times itself, that base 3x minus 2, that binomial by itself, and you use a FOIL method. Okay? Now what we're going to do is we're going to factor this trinomial. All right, so let's suppose we had x squared plus 22x plus 121. So x squared plus 22x plus 121. Okay? Now, you could do this the way you've been doing it. You could use trial and error. Notice that since the coefficient of x squared is 1, you could use the method you learned in the previous section. It really doesn't matter, but you need to still understand what a perfect trinomial looks like. Okay? What a perfect trinomial looks like. A perfect square trinomial. All right, so if I use previous methods, you could go to trial and error. This is trial and error. So x times x is x squared. 121, the possibilities, let's say, is 11 times 11. The last sign's positive. That means that both signs in here are going to be the same, and they're both going to be positive. And you check yourself. The outer is 11x. The inner is 11x. And when I add them up, I do get 22x. 22x. So there's your answer for that. Okay, that's using previous methods. Okay, but what I want you to think about is this. All right, so let's think about this. I'm going to rewrite it over. And I want you to look at that last term right here. That last term and that first term. See that first term? If I square whatever goes in here, I need to get x squared. So that's going to be x. Okay, x times x is x squared. Over here, 121 is a perfect square. All right, so hence that phrase perfect square right here. So there's going to be some terminology here that's the same as this. So x squared is a perfect square because I can write x squared as x in parentheses times itself. 121 is a perfect square because I can write 121 as 11 times itself. Okay? And notice what happens. If I take x and 11 and multiply them together, I get 11x. All right? And if I multiply by 2, I get 22x. So x times 11 is 11x. Multiplied by 2, I get 22x. So that means that this right here is a perfect square trinomial. Okay, now you may say, well, why'd you say multiply by 2? Because remember, over here, the outer and the inner were the same. The outer and the inner were the same. So you see this 25 right here? is 25? Remember, that is 5 squared. And you see this x right here? That is x squared. So if I multiply 5x, 5 and x, I get 5x. That's one of the outer and inner terms, but how many are there? There are 2. So you multiply by 2 to get this 10x. So 5 times x is going to be one of your either outer or inner terms. Does not matter, but there are 2 of them. So that's going to be times 2. So here, I get x times 11 is 11x, and if I multiply by 2, I get 22x, which is what this is. So this right here is a perfect square trinomial. All right, so what that means is this: since that's a perfect square trinomial, that means I can write this as x plus 11 squared. X plus 11 squared. And that will be your answer. Now you can check it. Go ahead and check it. X plus 11 times x plus 11. X times x is x squared. The outer is 11x. The inner is 11x. And the last is 11 times 11, right here. 11 times 11 is 121. And so I get x squared plus 22x plus 121. All right, so there's your answer. So again, this is a perfect square trinomial. All right, now here's what a perfect square trinomial looks like in general. All right, so it'll look like this. Perfect square trinomial. So it'll look like a squared plus 2ab plus b squared. So the first term is going to be something squared. The last term is going to be something squared. See how I wrote 25 as 5 squared? And you see how I wrote x squared as x squared? That's your a squared and your b squared. Okay, so that's a squared, b squared right here. All right, and then your trinomial right here. This trinomial is a perfect square trinomial because if I take x and 5, if I take a and b, so a and b here are x and 5, and I multiply them together, I get 5x. And if I double it, if I multiply by 2, I'm going to get this middle term. And so if I multiply by 2 and I get this middle term, then this is a perfect square trinomial, which means you can write it as a binomial squared. So a perfect square trinomial can be written as a binomial squared. So a perfect square trinomial can be written as a binomial squared. So it'll look like this. It'll look like a plus b squared. So this right here is equal to a plus b squared. All right, but you can also see this. Instead of seeing the middle term being positive, you can see the middle term being negative. All right, so everything's the same except for that middle term. So if I can write the first term as something squared and the second term as something squared, and when I multiply a and b together and I double it and I get that middle term, then it's a perfect square trinomial. So that means that then I can factor it as a minus b squared. A minus b squared. All right, so we're going to summarize all of this in this next example. So watch this next example. Suppose we had this. Suppose we had x squared, okay, x squared minus 16x plus 64. Now, you can use previous methods. All that method you learned before, trial and error, the coefficient is 1. You can use sum and product. It doesn't matter. But think about the two. But think about the perfect square trinomial. So the question is this a perfect square trinomial? Okay, perfect square trinomial. That's what I want you to think about. Is this a perfect square trinomial? All right. So it is if this happens. Okay, so listen carefully. Take the first term, and can I write it as something times itself? So is this right here a perfect square? Is x squared a perfect square? The answer is yes, because I can put an x inside the parentheses, and x times x is x squared. is 64. Remember, this is always note that a perfect trinomial, this last term has to always be positive. It cannot be negative. It has to be positive. Must always be positive. Okay, must always be a plus symbol. So can I write 64? Is 64 a perfect square trinomial? Yes, it is. I'm sorry, a perfect square term, excuse me. Is 64 a perfect square? The answer is yes. 8 times 8 is 64. Remember, your perfect squares are, okay, your perfect squares are 1, 4, because 1 squared is 4, 2 squared is, 1 squared is 1, 2 squared is 4, 9, because 3 squared is 9, 4 squared is 16, so these are your perfect squared. 1, 4, 9, 16, the next one's 25, next one's 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and so on. So there's an infinite number of them. All right, so we're going back here. Is this a perfect square trinomial? Well, we're in the process. First of all, here's A, here's B, right here. This is A, this is B, A, B. Okay, so if I multiply A and B together, x times 8 is 8x, and if I multiply by 2, it's always times 2. Remember, the outer and the inner, the outer and the inner are identical, so that's where that 2 comes from. There are 2 of them. Okay, so if I multiply by 2, I do get 16x, which is what this was. So this is a plus and this is a minus. All right, so this works. So this right here is a perfect square trinomial. So yes, it is. So now we can factor x squared minus 16x plus 64 as a binomial squared. Since this is a perfect square trinomial, we can always factor as a binomial squared. And all you do is this. X times x is x squared. 8 squared is 64. And since the last sign's negative, you put a negative in here. I'm sorry, since the middle sign's negative, I need a negative. All right, you can always check yourself. Check. X minus 8 times x minus 8. FOIL it out. X times x is x squared. The outer is negative 8x. The inner is negative 8x. And the last, negative 8 times negative 8 is a positive 64. And when I add them up, I do get negative 16x plus 64. All right, and so that's what you wanted. All right, so this was a perfect square trinomial. Notice the thought processes we went through to determine if this was a perfect square trinomial. Okay? All right, let's look at the next one. Suppose we had this. All right, suppose we had this. Let's suppose we had 16a squared minus 24a plus 9. 16a squared minus 24a plus 9. Now again, you can factor this using previous methods, but let's talk about, is this a perfect square trinomial first? That was the intent of this particular lesson. So is this a perfect square trinomial? All right, if it is this, then that means you can write it like this, like one of these right here. A squared plus 2ab plus b squared, a squared minus 2ab plus b squared. Okay, that's what that means. So let's see if we can. All right, let's first of all fill in the C if 16a squared is a perfect square. Is 16a squared a perfect square? Yes, it is, because I can write it as 4a times itself. 4a times 4a. Is 9 a perfect square? Yes, it is, because I can write it as 3 times 3. All right. Now, see, this is a minus. So I'm going to say minus 2, remember it's always 2 because the outer and the inner, times AB. So 2 times 4A times 3. Don't forget to write down the plus symbol here. So what you got to check now, is this the same thing as this? 2 times 3 is 6. 6 times 4 is 24, so I do get 24a. So the answer is yes, this is a perfect square. And so 16a squared minus 24a plus 9 is going to equal a binomial squared. And all you do is, remember, it's just a, since that's some subtraction, you can say a minus b. A is 4a, so 4a times 4a is 16a squared. For 9, I need 3, but it has to be a minus sign in the middle. So there's your answer. So 4a minus 3 squared. And always check yourself. Check. I can see if this works. 4a minus 3 times itself. So 4a times 4a is 16a squared. The outer, 4a times a negative 3 is a negative 12a. The inner, negative 3 times 4a is a negative 12a. And then a negative 3 times a negative 3 is a positive 9. And when I add them up, I get 16a squared minus 24a plus 9, which is what you wanted. So notice, always ask yourself, is this a perfect square trinomial? Check the first and the last first. First term, can I fill in the parentheses? Second term, can I fill in the parentheses? And then you got to check the middle term. So you take a and b, multiply by 2, and see if you get this 24. All right, if you can, then this is a perfect square trinomial, and then you can factor it as a binomial squared, where this is your a, the first parentheses, this is your b, second parentheses, and the sign in the middle is determined by this middle sign. Okay, if that was a plus right here, then that would be a plus, or a plus 3. All right, let's look at number 4. Let's see this one. Suppose you had, suppose you had 2n squared minus 28n plus 98. All right. Now, right away you know that this is not, this term right here is not a perfect square, nor is this term. But remember, the first thing you always got to check and see is does this polynomial have a GCF other than 1? It does. The GCF here is going to be 2. So the first thing you want to do is to factor out the 2. So I get 2 times n squared minus 14n plus, and what's that? This is, what's that, 49? So 49. All right. So now, work on the side with this. So let's look at this. All right, look at that. So, question is this a perfect square trinomial? Okay, so think about what we just talked about. It is a perfect square trinomial if I can take the first term and write it as something squared. I can take the last term and write it as something squared. And the middle term is either going to be a plus or minus, but it'll be 2 times AB. And so if that middle term ends up being the middle term I want, then it is a perfect square trinomial. All right, so here's a question. Is n squared a perfect square? The answer is yes, because I can write it as n. Is 49, remember that's plus right here. Is 49 a perfect square? The answer is yes. I can write it as 7. Now you got to check the middle term. I need a negative 14. If this is a perfect square, that means, remember this is subtraction, so that means I can write this as 2 times a, b. A is n, b is 7, and so the question is this right here going to give me that? And the answer is yes. A negative 2 times n times 7 is a negative 14n. So this right here is a perfect square trinomial. So this is a perfect square trinomial. So that means I can write it as a binomial. I can write it as a binomial squared, and it's just a minus b. So it's n minus 7. But check yourself. Check yourself if you need to. You don't have to, but check. N minus 7 times n minus 7. So the first n times n is n squared. The outer n times a negative 7 is a negative 7n. The inner, negative 7 times n is a negative 7n. And the last, a negative 7 times a negative 7 is a positive 49. And when I combine like terms, I get n squared minus 14n plus 49, which is what I wanted. So this right here is a perfect square trinomial. So since it is a perfect square trinomial, based on this, I get that. And I check it, and I get this. Okay? Now, that is going to go here. So don't forget, you want to factor this. So 2 has to be part of your answer because that was your GCF. And we get 2 times n minus 7 squared. And so that's the answer. Now, if you want to, you can write it as 2 times n minus 7 times n minus 7. Does not matter. But since the binomials are the same, just write it as 1 binomial squared. All right, so that was number 4. All right, let's look at 1 or 2 more. So let's suppose we had this one. All right, number 5. All right, let's suppose we had 16y squared plus 40y plus 25. All right, suppose I had that. So 16y squared plus 40y plus 25. And again, you can factor this using previous methods, trial and error. But let's just talk about different the perfect square trinomial. Let's just continue talking about that. So you have a perfect square trinomial. This is going to be a perfect square trinomial if you can write the first term as something to a power. You can write this last term as something to a power, and see how this is a plus symbol. And you can write the middle term right here as 2 times ab. All right. And so if you can write this like this, then this is a perfect square trinomial, and your answer will be a binomial squared. All right, so let's check it. Can I write 16y squared as a factor squared? And the answer is yes, because that's 4y. 4y times 4y is 16y squared. Plus 25. Can I write 25 as a perfect square, something squared? The answer is yes. It is 5. All right, now we got to make sure that this 2ab gives us 40y. So I get plus 2 times, all right, a is 4y times b is 5. And all you got to do is check and see. Remember, this is 2 times a times b. So a is 4y. This is your a right here. And this is your b. So when I multiply this out right here, 2 times 4 is 8. 8 times 5 is 40. 40 times y is 40y. I get this back. All right, now what that means is that I wrote this in this form right here, and this is a perfect square trinomial. Which means that I can factor a perfect square trinomial as a binomial squared. And so it's just a, this is plus, so it'll be a plus b, so this is going to be a plus b. So a here is 4y plus, and b here is 5. So there's your answer. So 16y squared plus 40y plus 25 is going to equal 4y plus 5 times itself. All right. So, and you can check it. You'll see that when you FOIL it out, you're going to get this back. Okay. So that was a perfect square trinomial. Let's see if I can find one more that we can do. Let's look at 15 at this example right here. Suppose I had p squared plus 12pq plus 36q squared. All right, suppose I had that. So p squared plus 12pq plus 36q squared. Okay, so let's now again you can use trial and error. You can use as the section that talked about the coefficient being a 1. It doesn't matter. But let's continue talking about a perfect square. And I'm going to go ahead and change this to a minus right here. Since this was a plus, let's just change this to a minus. All right, so let's see what we get. So if I can write this, so that way it looks like a squared minus, see this is minus, 2ab times, plus b squared. Then I can write this to make it look like this. Then this right here is a perfect square trinomial. This is a perfect square trinomial, which means I can write it as a binomial squared. I can write it as a minus b squared. Okay, so notice every term looks the same from here and here, except that the middle term's positive here, the middle term's negative here, and notice how the, oops, I forgot to write this as binomial squared. So notice how the factored part looks. This is a plus b squared, this is a minus b squared. All right, so let's see if what we get here. So p squared, I can write as p in parentheses times itself. 36q squared is 6q in parentheses times itself. All right, so now I need to check for that minus 2ab. Minus 2 times a is p. That's a, so a is p, and b is 6q. And I need to check and see if this right here is going to give me that. All right, so a negative 2 times 6 is negative 12. P times q is pq. So this right here can be written in this form. So this is a perfect square trinomial. So I can factor. So that's going to equal a minus b squared. So it will be p minus, and b here, 6q. So p minus 6q times itself, or you can say p minus 6q times p minus 6q. And there's your answer. All right. Now, remember, you could have done trial and error. So let's look at that same problem. You can use other methods. Other methods discussed. But I did need for you to understand what a perfect square trinomial looks like and how to factor it. But if you have the same problem here, p squared minus 12pq plus 36q squared, just doing, now remember the GCF is 1, but just going directly to the two binomials, first times first, using FOIL, you get the same thing, and it's quicker. I mean, this is obviously quicker, but I do need you to understand in terms of perfect square trinomial why it's called a perfect square trinomial. All right, so it's called a perfect square trinomial because I can write the first term as something squared. I can write the last term as something squared, and the middle term will either be a plus or minus twice AB. All right, so I can take AB, multiply by 2, either a negative or positive 2, and I get the middle term. Then this is a perfect square trinomial. Okay? All right, but it is quicker. Really, it is quicker if you kind of do this. So watch, p times p is p squared. For 36, there's 12. There's 6, 6. There's 9, 4. Let's try 6, 6. So let's put 6q, 6q. The last sign's positive. That means these signs in here are going to be the same, and they're both going to be negative. Negative, negative. And see, there's your answer. But let's check it, though. Let's check the FOIL. P times p is p squared. The last is negative 6 times a negative 6 is a positive 36. Negative 6q times negative 6q is a positive 36q squared. And the outer is negative 6pq. The inner is a negative 6pq. And when I add them up, I do get a negative 12pq, which is what you wanted. So it is quicker if you kind of use the trial and error method, but knowing why this is called a perfect square trinomial is also still important. Okay, so that's going to be the end of this section, of this